In this video, we are going to look at a couple examples of being able to sketch functions. Now, with these two examples, the biggest thing that we have to be able to do is you have to be able to identify what's called the parent of your function, and then you need to be able to identify points that fall on that function's graph. So when we look at this first one, we have negative 2x squared. So the first thing you want to do is identify your parent function. And in this case, that parent function is going to be x squared. Now, in order to graph it, the easiest thing to do is to just go ahead and create yourself an XY table. So in this case, we would have our XY table, and you would go ahead and we would choose values for x. So the easiest place to start is at 0. You would plug a 0 in for x, so 0 squared is 0 times negative 2 gives you 0. So in this case, we already know that our first point that we have is going to be here at the origin, 0, 0. Now the other thing that we know is that we have this negative. So this negative here is going to tell you that my graph is going to open down, which means the vertex is going to be at a maximum point. Now with this, the next thing I would do is I would go ahead and I would look at 1 and negative 1. So if x is 1, you plug it in. So 1 squared is 1 times a negative 2 is negative 2. And then I can look at negative 1. So negative 1 squared is 1 times negative 2 is negative 2. So I can graph those points as well. So I have the point 1, negative 2, so 1, 1, 2. And I have the point negative 1, negative 2, so negative 1, down 1, 2. Now the next thing that I would do is I would go out one more, because it is always a good idea to have 3 to 5 points on your graph. And so I would look at 2 and negative 2. So 2 squared is 4 times negative 2 is a negative 8. Negative 2 squared is 4 times negative 2 is negative 8. So here we're going to go over 2, we're going to go down to negative 8, and then we're going to go over negative 2 and down to negative 8. So we have graphed 5 of our coordinate points. So we're going to go ahead and kind of connect our little dots here, thus graphing our graph. Okay. Now with this, if you take a look at what you have, not only did we identify what the graph was, but we also identified 5 points that you could find on that graph itself. Okay, so those are kind of the two basic things that you need to be able to do when graphing your functions. Alright, let's look at one more here. This one instead is going to be an absolute value. Now just like before, here we have this negative, which in this case means that we are still going to open down. And the absolute value, okay, so your absolute value means you're going to have the V shape. So in this case, my parent function is going to be the absolute value of x. And again, I would go ahead and just simply create an XY table. And with these, I would do very similar to what we did with the quadratics. I would start from negative 2 and work my way up to positive 2. Okay. So if we look at this, we can say the absolute value of negative 2 is 2, because the negative washes away. 2 times negative 3 is a negative 6. That means down here at 2, we're also at a negative 6. Now, at negative 1, the negative washes away. 3 times negative 1 is a negative 3, means the same thing at 1, negative 3. And then at 0, we're going to be at 0. So I have my 5 points. So now all I have to do is go into my graph and graph those. So here I've got, starting at 0, 0, I then go 1, negative 3, -1, -3. I then go 2 down to -6, and then -2, -6. And in this case, I'm going to use a straight edge so you can see it, but here this is actually going to be straight lines because absolute value deals with straight linear lines, whereas the other one was a quadratic, which is a curved parabola. So in this case we do have that V shape, which is what we wanted and what we were looking for. So that is everything that you would need to know in order to get started in being able to graph other functions besides linear. So if you have any questions, please let me know. Otherwise, I hope you enjoyed this video, and I'll see you next time.